Nung everywhere, or how tiny insects can walk on water without sinking. There's a hidden force at play, and today, we're diving into one of the coolest mysteries of nature: surface tension. Today, we'll explore this fascinating physical property that plays a significant role in the behavior of liquids, impacting everything from everyday phenomena to advanced scientific applications. Definition of surface tension. Surface tension is the force that acts on the surface of a liquid, causing it to behave like a stretched elastic membrane. This force is responsible for phenomena like the formation of water droplets and insects walking on water. Cohesive and adhesive force definition. Cohesive forces are the attractive forces between molecules of the same substance, while adhesive forces occur between different substances. Together, these forces influence how liquids behave at their surface. Surface tension in drug manufacturing. Surface tension plays a crucial role in drug formulation, affecting a drug's chemical activity, adsorption, dissolution, and bioavailability. Understanding surface tension helps overcome manufacturing challenges and improves product performance and quality. Revision. Before diving deeper, let's quickly revise what we've covered. Surface tension is a fundamental concept, influenced by cohesive and adhesive forces, and it affects numerous applications, including drug formulation. Surface tension. Definition. Surface tension is like an invisible skin that forms on the surface of a liquid. Molecules stick together, creating a tight surface. This is why water forms droplets and why small insects can walk on water without sinking. Other ways to define surface tension. Surface tension can also be explained by everyday examples. Think about a water droplet. Why does it stay round instead of spreading out? This is due to surface tension. Scientifically, surface tension happens because molecules at the surface are pulled inward, creating a stable layer. A simple analogy: imagine a trampoline. When you press down, it stretches but holds together, just like how surface tension keeps the liquid surface stable. Types of surface tension. Surface tension can be classified into several types, based on various conditions and factors that influence it. Let's look at the different types. Static surface tension. Static surface tension refers to the surface tension of a liquid at rest. It's observed when there is no movement or disturbance, like a still glass of water, or the surface remains undisturbed. Dynamic surface tension. Dynamic surface tension occurs when the surface tension changes over time. This happens when liquids are in motion, such as when water is splashed or bubbles form in soap water. Slide 11. Interfacial tension and critical surface tension. Interfacial tension is the force between two immiscible liquids, like oil and water. This creates a boundary where the two liquids don't mix. Critical surface tension is the specific tension at which a liquid completely spreads out over a surface, like when water evenly spreads on a clean glass but forms droplets on a waxy surface. Cohesive force. Cohesive forces are the attractive forces between molecules of the same substance. In surface tension, these forces help create a tight surface by pulling molecules inward. For example, water beads up on a waxy surface because the water molecules prefer to stick to each other rather than the surface. Adhesive force. Adhesive forces occur between different substances, like water sticking to a glass surface. When adhesive forces are stronger than cohesive forces, the liquid spreads out. When cohesive forces dominate, the liquid forms droplets. Balance. Between cohesive and adhesive forces. Surface tension is a balance between cohesive and adhesive forces. Stronger cohesion leads to high surface tension, forming droplets, while stronger adhesion results in low surface tension, causing the liquid to spread. Real-world examples of cohesion and adhesion. Let's look at some examples. Water droplets on a lotus leaf show strong cohesion, as the water molecules stick to each other. The lotus leaf has low adhesion, so water rolls off easily. On the other hand, water sticks to a glass surface due to stronger adhesion between water and glass. Adding soap to water weakens the cohesive forces between molecules, making it easier for water to spread. This is why soap is effective at cleaning surfaces. Also, capillary action, like in plant roots, occurs when both cohesion and adhesion work together to pull water upward through a narrow tube. In conclusion, surface tension is a key concept that explains various physical phenomena. From its role in liquid behavior to its influence on applications like drug manufacturing and cleaning, surface tension is integral to our daily lives and scientific advancements. Let's test your knowledge with a quick question. Which of the following best explains the role of cohesive forces in surface tension? They help a liquid spread out on a surface. B. They cause molecules at the surface to be pulled inward, minimizing surface area. C. They reduce the attraction between molecules in the liquid. D. They allow liquids to mix easily with other substances. Here's another question. Why is surface tension important in drug formulation and manufacturing? A. It determines the weight of the drug molecules. B. It affects chemical activity, adsorption, dissolution, and bioavailability. C. It prevents drugs from dissolving in water. D. It has no impact on pharmaceutical applications. The correct answer is B. Surface tension affects the dissolution and bioavailability of drugs. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and click the bell icon to get notified of future content.